As always, let's read the question first. Go ahead and do that now. I'll wait. So we need to know that displacement means a change in position, but we're only interested in the change in position from the time interval 1 second to 6 seconds, here to here. So it looks like we're going to be going from a position of 1.8 meters to a position of 0.8 meters. A nice little trick. If you always do the final position minus the initial position, you'll get the sign right every time. In this case, negative slope, negative displacement should make sense. Okay, on to number 2. Read the question. So to solve this one, we need to know that the slope of a position versus time graph is going to give us the velocity. Remember, when finding slope, we need 2 points on the graph. I recommend always using the first and last points. That's here and here. So our position is changing from 7 to -8 in 10 seconds. I leave it to you to find the slope. Number 3 asks us to select the best description of the motion from a list. My advice is don't look at the list, just describe the motion. We know that a straight line means constant velocity, so from 0 to 3 seconds we have a constant velocity. Then the velocity changes. The key thing to remember here is steepness. A steeper slope means faster velocities, so the student speeds up. Don't forget that a steep slope could be negative in some cases as well. We want to know which car is ahead, so we need to know where the finish line is. Since they're moving in a negative direction, let's place the finish line here at 100 meters. Now, at t equals 6 seconds, who is closer to the finish line? I'd say car B. So in this one, we're trying to match a velocity time graph to a position time graph. Again, I'd suggest not looking at the choices first. Instead, draw what you think it should look like. In this one, we have a constant positive velocity, so the position time graph would look like this. What would it look like if the velocity was negative? Try drawing that one for yourself. Make sure and read this one carefully. What are they asking us to find? Now notice that it's a horizontal line on this velocity time graph. If it was a position time graph, there wouldn't be any change in position, but this is a velocity time graph. We can find the change in position by finding the area under that red line. At 50 meters per second, after 1 second, how far did it go? Do you see how it's just 50 times 1? But we want to know about 1 second to 4 seconds, which would look like this. So that's going to be 50 times 3 for a displacement of 150 meters.